Okay, so in this video, we are going to discuss about the examples. So we are going to continue with the examples. So the question says, suppose you are a father and you want to have a bright future for your newborn daughter. You wish to send her to MTSU when she is 18 years old. Based on current institution for MTSU, you assume for 4 years she need this much in her account when she turned 18 years old. You're planning to contribute monthly, level payment for 18 years, fund an effective rate of 3%. What would be the monthly payment amount? So what we are going to do, we are going to use the calculator. But before that, let's collect what's in here. So you have you need you need 112,550. So let's write what we need. Future value is, and then in her account when she turned 18 years old, and then it's just newborn. Okay, so so the time you have time wise you have 18 years. So let me write here 18 years, and then from 18 years old you need it for 4 years. And then you're planning to contribute monthly for 18 years. So contribute monthly. And then your rate is 3%. Okay, this is effective interest rate. That means basically annual rate. Okay, assume it's annual. And what would be the monthly payment amount? So the question is a monthly payment amount. Okay. So let me and then by the way, the question is not really telling you when the father start depositing money. So we can think it as at the end of the period. So basically annuity immediate. So let's solve this problem. Let me show you calculator. Okay. So in this calculator, let me yeah. Oh, I can't share the both at the same time. Let me make it like this and then share the calculator. Oh, now I can show you the calculator. Okay. So in calculator, you can see these functions. Okay, so you can see this. This and N, IOY, PV, payment, and future value. So let me write those ones. N, then IOY, PV, payment, and future value. Okay. What we are going to do, we are going to use these calculator functions to solve this problem. Okay. FV, this one stands for future value. Payment is payment amount. And present value is present value. PV is present value. And IOY is nominal rate. And N is basically number of payments. Okay. Now, if you let me show you this calculator. If you click second and I over Y, you can set up how many times it's compounding. So let me second I over Y. You can see here P over Y. Okay. So that's a payment per year. And then if you use the arrow, you can see COA, that's compounding per year. So if you click second plus I over Y, and that would give you two things. P over Y, that's the number of payments per year. And then COY, number of compounding per year. Okay, so now let's solve this problem using this calculator function. So how many years? Number of payments is 18 times 12. Okay. What's the nominal rate? IOY is 3%. Now you have to tell the calculator how many times compounding. This is nominal, remember it's nominal. So if it is nominal, but this rate is really effective rate. So nominal and effective both are same if compounding per year is 1. Okay. So COY you need to set 1. And the payment per year is going to be how many payments per year? That's going to be 12 payments. Okay. Then we can we want to find the present value is actually 0 because right now it's no value. Future value at the end of the 18 years, we need this much in our account, and we are really solving for payment. Okay. So let's enter this into calculator and see what we get. Okay, so first let me clear the calculator function. So I would click second, clear TVM, or second, clear work. Okay, so now I would send 18. So N is 18 times 12. Let me multiply this, 18 times 12. That's 216. That's going to be N. Then 3% is for IOY. And then I click second IOY, and here payment per year is 12. Enter. I use the arrow, compounding per year is 1. Okay. Then present value is 0. Oh, wait. Compounding per year is 1. And then I will click second quit. Then I will click the 0 for present value and 112,500 for future value. And then I need to solve for payment. So I will click compute a payment. So this is the payment amount. So the payment amount is basically negative 394.99. So that's the payment amount. Okay. Now you may wonder how I got this really. Like in theoretical wise. In theoretical wise, you have to solve using that formula. What's the formula? Future value equal present value time A, this is annuity, N, and not annuity, but it's annuity media, A, N, and I. So that would, the future value is payment. So from here you can write 112,550 equal payment time. What's the formula for this one? 1 minus V to the N over I. 112,550 payment. And what's the rate? 1 minus V N. What is the N? N is 18 times 12, which is going to be what? That's going to be 216. And the rate I. Now we have to be very careful. What is the rate? Because 3% is really for annual rate. Okay, so I need to calculate this I is actually monthly effective rate. So I have to solve that before I continue. So I can write the rate 1 plus I to the 12 is 1.03. This I is effective rate per month. And then I can solve for I. So that would give me around 0. When I solve this, I would get 0.2466%. Okay. So that's the rate you should use here. So in that case, we become 1 over 1.02466. Okay. And the I become 0.002466. And then you solving this equation, you can get the payment. Okay. But I would not recommend that. I use the calculator. Okay, so here the question asks find this quantity given the effective annuity due for 8 payments. It's 8 is for number of payments. Under the defective discount rate is 10%. So here instead of interest rate, you are given the discount rate. So you can right away, you can write the formula to find the interest rate. From here, you can see 1.1 and 1 minus D equal 1. And from here, you can get D. And then once you know that, then you can solve this. We can calculate it. That's going to be 1 minus V to the 8 over D. So it's going to be 1 minus V is defined as 1 over 1 plus I, which is from here. Okay, actually, you don't need to solve for I, because from here you can see 1 plus I and 1 minus 0.1 equal 1, which is mean 1 plus I equal 1 over 0.9. And then you can substitute that in here. So that will basically 1 over 1 plus I is 0.9. So or which is called as V. Okay, so basically actually V is 0.9. So 0.9 to 8. D is given 0.1, and then you can get the answer. Okay. Here's another example. What amount must you invest today at 6% interest rate compound annually so that you can withdraw 5,000 at the beginning of each year for next 5 years? So let's try to use calculator. What amount must you invest today at 6% interest rate compounded annually so that you can withdraw 5,000 at the beginning of each year for the next 5 years? Okay. So if I draw the timeline, it's look like this: 0, 1, 2, 3. We need how many payments for next 5 years? So 1, 2, 3, 4, 5. So here I want to withdraw money, payment, 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 and then here become invested amount. And the rate is 6%. Okay. So we can do the problem right away. So I can write future value, not the future value, present value. Oh, by the way, in this problem, this should be present value. Okay, so that means this one should be this one should be what? This one should be divided by, in the previous problem, 1 plus I2, 1 plus, because I need the present value of 112,150. So 1.032 to 18. Please make that correction. Okay, so here, so we want to find the present value, how much we need to invest today. So present value is going to be 1 minus. First, we can write the payment in the equation. Payment time, A, this is what? This is annual due. How many years? 5 years. So A5. And what's the rate? Rate is given as 6%. And it's compound annual, so it's effective rate. Okay. So present value, that's the question. Payment is 5,000. And then this formula, if I write 1 minus V5 over I. And V is 1 over 1.06. I is 0.06. Okay. So you can solve it mathematically. Now let's try to solve this using our calculator. So in our calculator, you have a few functions. You need to enter n. N is 5, and then you have to enter rate I over y, which is 6%. Then you have to enter compounding per year, it's once. Payment per year, it's 1. And then you need to know the present value. That's what you want to really solve. Payment, you know the payment, that's going to be 5,000. And the future value, that's 0. And then you are solving for payment. Okay, let's use our calculator and see whether we can do this. So I'm going to clear this. Second clear work. So it's going to be clear everything. Let me enter this number. So 5 for n, and then 6 for IOY, and then click second IOY. Payment per year is 1. By the way, I think click the second clear TV. It looks like my one is not clear. I usually like to clear the entire memory. So second memory, click enter. That would clear the memory. Okay, so now let's enter. 5 for n, 6 for IOY, then second, this one is payment per year is 1, compounding per year 1. So second quit. Then you click the payment 5,000. Since you are withdrawing, it's positive. And the future value at the account is going to be at the end of it 0. And you are solving for percent value. So compute percent value. And you will get the percent value as negative 21,068. Okay. So you need to deposit that much to do this withdrawal. So this is how much you need to deposit today. Okay, so here's another problem. What amount will accumulate if we deposit 5,000 at the beginning of each year for next 5 years? Okay, so 0, 1, 2, 3. 5,000, 5,000, 5,000, 5,000 for next 5 years. So 5,000. So how do you calculate? The question asking future value. Remember, future value is basically present value time 1 plus I to the, in this case, will accumulate at the end of the year 5. Okay, so you have to ask that question at the end of the year 5. So this is the year 1, this is year 2, year 3, year 4, and the end of the year 5 is here. Okay, so future value at here. So I can write future value equal percent value 1 plus I to the 5. Okay, that's one way. The other one is I can write the future value is payment time S5. This one is annuity due, so I would use a double dot. And the rate is 6%. It's effective for 6 years. I mean, effective for 5 years. Okay, so now let's solve this payment. And this formula, if you look at this, it's 1 plus I to the 5 minus 1 over D. Okay. And what's the I? I is 6%. Then what's the D? You can always solve D using I over 1 plus I. Okay. So use that. Now that's the one method. And if you use the calculator, we can use N is 5. Payment. Since we are deposit is 5,000. Present value at very beginning, there was nothing in the account, so present value is 0. Future value, that's what we want to find. And the compounding per year is going to be 1, and payment per year is going to be 1, and the rate is going to be 6%. And then this is, so this is what we want to solve, okay? And this is annuity D problem. Now we didn't do that kind of problem yet. So let's do this. Let me bring the calculator and let me clear the memory. Just to be sure, I'm going to click second memory. Click enter, everything is clear. Let me enter 5 for N. negative 5,000. When negative sign, you use this sign, okay, in here, negative sign for payment. And then 0 for present value. And then compounding per year is 1, rate is 6%, percentage rate, 6%. Then second payment per year is 1, spread down, compounding per year is 1, so everything is good. So second quit. And then I need to change the calculator to know that it's due problem. So the way you do it, you click second payment. And then here I can change whether it's end or end mean the annuity median. If you use the arrow, it's become second, click second step, it's become the begin. Okay. So second quick. So now it's the begin, you can see BGN here. So now I would say solve for future value. So compute future value. So you can see it's 29,876.59. So 29,000. That's the future value. Let's do this problem. This one says over the next 30 years, you deposit money into retirement account at the beginning of each year. The first 10 payments are 200 each. The remaining 20 payments are 300 each. The effective rate of interest is 9%. Find the percent value of this payment. So here you have time 0, 1, all the way up to 30 years. You are depositing money into account at the beginning of each year. Okay, so all the way up to 29. 30. So the first 10 payment are 200 each. So here is 200, 200, 9, 200. Then the 10th one is going to be 300. And the last one is here, okay, 300. The rate is 9%. Find the percent value. So we want to find the percent value. Okay. The first term, yeah. So the question right away, you can see it'll be different from the previous problem. One approach would be you can think this 300 as 200 plus 100. This 300 as 200 plus 100. Okay. Then right away you have two cash flow sequence. So here you have 200. And then there's another one. Like that. So let's first find the percent value of cash flow 1. So this is, so I'm going to find the percent value at time 0, and then the percent value at time 0. Okay, so that is cash flow sequence 1, is a cash flow sequence 2. So this one is more, if I use the formula, it's going to be 200. It is annuity due, so a double dot. And then how many are there? There are 30. What's the rate? Rate is 9%. Okay. Now, if I, so that's the formula you can use. The second one, you can see I can find the present value at time 10. Okay, use the same kind of formula. But then I have discount back it to the time 0. So at time 10, present value of cash flow 2, sequence 2, that's going to be 100 times a double dot is because at the beginning, and how many are there? There are going to be 10. What's the rate? 9%. Then at time 0, you have discount back this cash flow again. So how you discount? You have to multiply it by v to the power 10. Okay, that's because you have to go all the way 10 years back. So then the present value of cash flow sequence 2 at time 0, that's going to be 1 plus, v to the 10. Let me erase this. 100, a double dot, 10. Okay. So you have to use your calculator. How you find this one using your calculator? You have n equal 30. Compounding per year, payment per year is 1, rate is 9%. You have to set due. Then also a payment going to be negative 200, future value 0, and you are solving for percent value. This you can solve for this one too, but then you have to multiply this one manually. Okay, so this one is what? Payment is negative 100. The n is the previous one n is 10, but 30, but this one is n is 10. Rate are going to be same. IOY is 9%. And then you can use the same part. But then you have discount by v to the power 10. Okay, don't forget that. So what is v? V is 1.1 plus I to the power negative 1. So we can say v is 1 over 1 plus I, which is 1 over 1.09. Same thing. You can do the rest. Okay, so here is another question. During 1998, Omar had a dividend payment of 100 directly deposited to his saving account on the first day of each month. Find the accumulated value of this payment at the end of the year if his saving account had a nominal discount rate of 4.8 payable monthly. Okay, so 0, 1, 2, 12. Okay, this is basically month. Okay, so if you really want, I can write 1 over 12, 2 over 12, 2 over 12. At the beginning of the month, $100. And then the last one would be the here. Okay. Find the accumulated value of this at the end of the year. So here we want to find the future value. So what is that? So if I write the formula, future value equal present value time 1 plus I to the 12. So in this case, we have to be careful what is rate we are talking about. Okay, so what is I? I is annual effect. I is monthly effective rate. The another way to do this, so basically you have to find the percent value using annuity. Okay. Another way to do this is you write the annuity symbol, payment, then write the S 12 I, and then you have to make sure that this is annuity, so you use the double dot in here. Okay, so the payment is going to be 100. Okay, so if I use this 100, 1 plus I to the 12 minus 1 over I. Yeah, I is basically monthly effective rate. Now this is nominal. Okay, so how do you get the I? Basically you divide. Okay, so you are given I12 as 4.8. That means I is I12 divided by 12, which is going to be 4.8 divided by 12. Okay. So that's the formula. Now, if you want to use calculator, you can write N is how many payments? 12. Compounding per year is 12 times. Payment per year is 12 times. Rate is nominal rate. Okay, so you would enter 4.8. And then future value, that's what you want to find. Present value 0. Payment is you are paying. No, you are getting. So it's plus 100. Okay. So let me use calculator. And this is, by the way, you have to set it to be due. Okay, so let me use calculator. Okay, so 12 for N, and then compounding per year is 12. Let me just set the rate. It is 4.8. Then second, here it's 12. Yeah, so we both are same. So second quit. And then 0 for percent value. Payment is 100. And then we are computing future value. And I'm getting 1,231.66. So that will be the answer. Okay, so I'm going to leave the rest of the problems for you to try. If you don't know how to do it, send me email. And there are a lot of problems here. Okay, so that's the end of the this video, and we will meet again to discuss about deferred annuities.